Starting the fourth session titled Challenges and Opportunities. Our first speaker is Dr. Márco Lizzul. He's an innovation manager at Varicon Aqua. He'll be speaking about economies of scale necessary for commercialization of microalgae business. Please welcome him on stage.
Good afternoon, everyone. I'd like to thank the organising committee for inviting me here today to speak. Hopefully the slide pointer will work. I don't know if it is. Is this working? It's nice and bright up here for those of you that haven't been on stage. Is it gonna... Oh, yeah, okay. We'll, don't. So do you want to stay here? Okay, and will this... Oh, okay, right, so the point does work. So, apologies, I've changed the title a little bit today, but it's still pretty much the same theme, really, looking at kind of opportunities and economies of scale within Saudi Arabia. Just a little bit about myself before I get into the presentation. So I have around 10 years experience working in the microalgae sector. I have a background in bioprocessing, biotechnology and associated technologies. I've worked with Varicon Aqua for some time now. I did my engineering doctorate at UCL, and then after that doctorate went on to work for Varicon Aqua, developed a photobioreactor called the PhycoLift, and Varicon Aqua commercialized that system. I have experience in a broad range of areas, but I'm an innovation manager at Varicon Aqua, so very much involved in managing the R&D and commercialization pathways for the technology. So just before I get into the meat of the presentation, I thought I'd just give you a little bit of background about Varicon Aqua. So we're a UK-based SME. We have business areas in four key areas for business. So we have photobioreactor technologies that we deploy worldwide. We have algae nutrients and that we again deploy all over the world. We do aquaculture products and services, and also increasingly consultancy services, as we're finding the algae industry is growing and this demand for these services is increasing. As I said, today we'll be mostly talking about economics, but we are one of the leading suppliers worldwide of photobioreactor technology, and we've worked at all sorts of scales all over the world with a broad range of partners, and all the way from academic institutions to commercial partners. So just before I get into the economics part of the presentation, I just thought I'd highlight a project we did at KAUST. So we're a supplier that can provide technology all through the scales, so from inoculation, batching up to production. At KAUST, we supplied some phycoconical systems which are used for inoculation, and also some phycoflows and phycopond systems, which were then used to inoculate the larger high-rate algal ponds that KAUST built. The next slide shows a nice picture of the systems we deployed at KAUST. So these 3 phycoflow systems are horizontal tubular serpentine systems mixed with a centrifugal pump, and in the front you have 3 small ponds that are used for testing and then used by Claudio and his team to feed into their larger ponds that they made. So I thought I'd give a brief overview of global algal production, but I don't want to get too stuck into this because I know this has been discussed at length over the past couple of days and also today. So, I think the algae sector very much is in that top area, split between food, feed, health and cosmetics. There are, some emerging areas, let's say. Some are more feasible than others. But I think, for the purposes of today, it's very much worth thinking of, feasible and tangible algal opportunities as being in that food, feed, health and cosmetics area. I would give perhaps one notable mention, because I am quite into wastewater treatment. I think of the future and emerging opportunities for algae, I think wastewater treatment is perhaps the one that has the most potential. but I won't be talking about that today. So a little bit of background on key production numbers worldwide. You'll notice, those of you that are observant, that there's probably been a broad range of numbers quoted over the past few days. It's a little bit hard to get this sort of certainty on the numbers because it's a small sector. Production numbers are always a little bit variable, and reports, some of them quote very high numbers. So, we believe that there's roughly somewhere between 20 to 25,000 tons of dry weight of microalgae being produced worldwide. And depending on how you value that industry, somewhere between 0.4 to 1 billion USDs and US dollars in value. And the market growth rate is somewhere between 5-7% depending on the sector. Some a little bit more, so spirulina perhaps growing a bit faster. You'll see in the bottom left some of those production numbers. You'll notice the squiggly line in front of that. There is still a huge amount of uncertainty, probably, really how much is being produced worldwide. But you can see spirulina and chlorella really dominate the global production. So the main part of the talk today is to look at the kind of potential for spirulina production in Saudi Arabia. And I think many of you will be aware of the kind of positives that are within the kingdom. So there's a large amount of land that's perhaps underused and not suitable for other types of agriculture. So growing algae could be a very interesting opportunity. There's a high amount of light, possibly even too much in some cases, but it's better to have more than less, generally speaking. You have high temperatures and also a range of temperatures in different locations in the kingdom. Obviously, fresh water is a concern. But there is obviously access to salt water on the coasts. Energy is cheap, which is a big plus. Labor can be low cost as well here, which is another benefit. And you also have access to capital markets internally within the kingdom and also externally. And location-wise, you have a good position here to export both to Europe and to Asia. So overall, I would say potentially one of the best locations worldwide to produce microalgae. So I want to talk a little about spirulina because that's the organism I want to focus on in this economic evaluation. So again, most of you probably know a lot about it, so I don't want to go into too much detail, but it's a filamentous blue-green cyanobacteria produced worldwide. It's been produced now for a number of years, so it's a pretty established product. Obviously, main production areas are in China, as been discussed previously during the conference, Southeast Asia and the US. There's a range of benefits, high protein content, and it's there's a few strains that are most commonly cultivated. Just a bit about the composition of spirulina. The key numbers of interest are the high protein content and also the kind of vitamins and trace elements that you can find within the spirulina, providing it's grown correctly. I won't be talking too much about phycocyanin today, but that's obviously another big area that spirulina finds itself in. So, as I mentioned previously, this is kind of some of the key production volumes and values worldwide. Probably somewhere in the region of 13,000 tons produced worldwide. These numbers I've seen double, I've seen a lot more as well, but I believe it's probably at that lower end. Typical production costs, again, somewhere between $8 to $20 per kilo. Some of the spirulina produced in China is a lot cheaper, but it's obviously a very different market in China, so hard to sort of say how it's been produced. Market value still, I guess, relatively low compared to other large agricultural crops, and the growth rate of spirulina is a bit higher than the average for other algae. B2C price range, this can be quite variable, but we're talking about here as a kind of standard spirulina product that will be dried and sold to the consumer, and that can often be found in powders or flakes. So you can see the market share mostly in North America and the Asia Pacific region. In Europe, there's some trends in increasing use now, especially of fresh pastes and various products like that. So I'm going to talk a little bit about a 10-hectare Saudi Arabian production site. This is a modeling exercise, so it doesn't exist, but it's basically, you might be asking the question, why start with a 10-hectare production facility? Well, looking at some of the leading producers worldwide, you can see that their facilities range between sort of 20 to 60 hectares. So, to enter at the lower end of perhaps 10 to 20 hectares is kind of a sensible entry point, I feel. You can see also the graph on the left. The cost of production, when you go from kind of 2 hectare to 10 hectare, you've got a big drop and you kind of enter that kind of sweet spot close to $10 a kilo. We believe if you get any bigger, the lowering of the cost of production is going to become more marginal. Obviously, there's not really any facilities that big, as far as I understand, in one consolidated space, so hard to know. But you can see that our modelled values versus the literature are quite similar. So we think a 10-hectare scale seems a reasonable entry level for a production facility of spirulina. So those of you that know Varicon well know that we're primarily known for photobioreactors, but in this case, we wouldn't recommend using a photobioreactor to produce spirulina on a large scale. And that's just mainly to do with the cost associated. You can see on the graph, production costs can be anywhere from 3 to 5 times higher. And so although that does come a bit closer as you scale up, we would definitely recommend high-rate algal ponds or open ponds, would be the most suitable production technology for a spirulina operation at that scale. However, it should be remembered that photobioreactors can provide a key part of any production chain. They can provide a clean inoculum, and they can also allow you to diversify some of the production with other organisms. So looking at the 10-hectare plant model, so this is a proprietary model that we have in-house. We've been developing over the years and obviously continue to improve as we do more and more projects. It's got about 400 different parameters, and essentially it considers all of the major or most of the major CapEx and OpEx elements. So area, mass, labor, energy, and financial constraints. You can see here we've drawn up some facilities. Obviously, it's not real, but it's a nice CAD image. You can see that as most production facilities, you'll start with some greenhouses, you'll start with some inoculation ponds, and possibly also some photobioreactors, and then you'll scale up into larger ponds as you go into production. So a little bit more about the model. So as I've discussed, it's a 10-hectare kind of model. The production ponds are around 4,000 meters squared production ponds, but there's also, as you saw on the image previously, a range of smaller production ponds that feed into those larger ponds. We're assuming around 30 tons per hectare produced, which is equivalent of about 15 grams per meter squared. We're used to a saltwater tolerant strain in the model, and we'd like to thank, obviously, Claudia has been working on that at KAUST, so we're kind of using that concept in this model. Drum filter harvesting and use of solar drying. The model is kind of, we haven't kind of focused too much on the after sales, but more as a simple B2B sales model, so we're not looking at the B2C elements. You can see here on the left the kind of basic summary of the kind of some of the key areas considered in the model. So to summarize the kind of findings in terms of the cost, total facility somewhere in the region, for the 10-hectare site of about 11 million US dollars, USD. And you can see that the kind of costs for the CapEx are split quite large chunks, obviously, for the facility, the earthworks associated with digging the ponds, and then also the other large elements kind of involved with the processing, downstream processing equipment. A small fraction for photobioreactors, which we always feel is kind of suitable as an inoculant, to produce a high quality inoculum. And then also some other kind of indirect and contingency costs as well. Looking at the OpEx for the 10-hectare facility, we've kind of got somewhere in the region of 2.5 million US dollars. You can see that the kind of big costs are kind of the mass total. So by mass totals, we're talking about fertilizer inputs, water, and these kind of any kind of mass and materials. You can see that the energy costs reasonably low, so I guess that's one of the real benefits in Saudi Arabia, and that's something that differs considerably from modeling this in other locations. You'll see normally that the energy cost is a much bigger chunk, so up to 25-30% of the costs. Staffing total, obviously you need a lot of people on a facility like this. It's a large agricultural facility. And then you can see that the recurring totals are quite expensive. So, you've got a lot of recurring costs to deal with. So that's everything like maintenance and things like that. So looking at the kind of annual cash flow of this facility, we're modeling around 3 to 4 years of payback. You can see the graph on the left. The first year is because of all the money you borrowed to fund the facility. So we're kind of borrowing to fund the facility, and then over 3 to 4 years, you eventually get back to a kind of payback period. As I mentioned previously, you're talking at about 11 million US dollars for a facility this size in this region. Working capital, we basically fixed that as the kind of as the OPEX costs annually, so you start with that, so you can see the total capital requirement at the beginning. We obviously took a loan out in the model to fund this, so a 40% loan, the rest would be financed by equity, but obviously you can toggle these parameters depending on the model. And you can see at the end, that's kind of a cost of production of about $13.5 per kilogram of dry weight spirulina. So to kind of conclude the presentation and summarize, production of spirulina in Saudi Arabia is viable and displays many potential opportunities. I think, the modeling that we've done so far predicts a payback of 3 to 4 years. Production costs are kind of comparable to other regions in the world. I think, additional work on the model and additional factors could bring that cost down as well, slightly closer to $10. I don't think that's a problem. Again, obviously, if you scale up to 20 hectares, then again, you should see that cost come down a little bit further. We obviously considered quite a lot of the local attributes of the region in this modeling. So, use of salt water, solar drying, cheap energy, and these are all big factors in bringing the OPEX down for the facility, and which make this region particularly interesting, to produce a spirulina or other algae at large scale. One thing I think I should just mention as well before I close off, which I didn't put on the concluding remarks, is that a lot of work still has to be done on regulation, on sort of developing a B2C market, whether that's either internally or externally. It's one thing to produce, a load of algae. It's another thing to then actually get that to market and sell that successfully. It's, that's that. In fact, that's probably the bit that's hardest. I'd say that, you can produce algae. It's been shown you can produce algae at scale, but getting a product to market at a good price point and with some good marketing to allow you to sell that on to the consumer is the biggest challenge, and I think that will be a challenge wherever you produce. But obviously, starting in Saudi Arabia from essentially no algal industry, that's probably one of the big things to really think about. So, we're at booth R06, so please come on over and have a chat with me. I'll probably be here as well and be on the panel. But if you want to check out our website, we're variconaqua.com, and my email address is there as well if you want to discuss further. Thank you.
Thank you indeed.